Assalamualaikum warahmatullahi wabarakatuh, and a good day to everybody. So now we are continue our chapter 3, equilibrium in particle. I think this is the last session. We need to have the example. We need to do the sum sizes. Okay, so basically what's the procedure for the drawing the free body diagram? It's very important. If you can't draw the free body diagram from the problem, you cannot extract the data, you cannot extract information, you didn't understand information, so you cannot be able to solve the problem. First one, we draw the outline shape. So basically we are referring to the X and Y standard reference plane. So the second one is to show all the forces in that particular problem. So we have the active force and reactive force. Active force meaning that the force that is tend to the particle in motion. So the reactive force is the constraint that prevent the particle to motion. So they are preventing the motion. For example, the support, so it actually prevent the motion. So identify each force. We need to know forces with the proper magnitude and direction. Later use the represent magnitude and also the direction. Okay, so we have the example here. So the sphere has a mass of 6 kg and is supported by this support hinge, and also the pulley here by the spring here. So draw a free body diagram of the sphere, the chord CE, and also the knot at C here. Okay, so for now we are focused on the sphere first. Okay, so now free body diagram on the sphere. So we have the chord CE and also the weight of the sphere. Notice that the mass is a 6 kg, so the weight is a 6 multiplied by constant G, the efficient constant. So we by the 6 multiplied by 9.81, so given by we have 58.9 Newton downward. This one is the gravity acting on sphere. So you can see here they have the chord CE. So the chord CE meaning it's the force of chord CE acting on the sphere. So they have the two forces acting on the sphere, so the weight and the force on chord CE. Okay. So now because in the chapter 1 we can analyze our subject, the problem is as a particle. We can now we want to analyze it. This one is a particle, so now we are focused on the point not C here. So how we want to eliminate this weight, and also we have because the knot C here is connecting the spring, the knot C is connecting B and A here, B cable A, B, C here. So also the chord C and also the weight. So now you want to focus in this one. We want to analyze it's a particle. Okay, so if we isolate the chord CE, so it's around the chord CE. So we have the two forces. In the upward is the force, because the knot is this knot C here acting on chord CE, and also the bottom one is the force of sphere acting on the chord CE. So we have the force on knot acting on CE, and then force of sphere acting on CE. Okay, so force on knot acting on CE, so force of sphere acting on CE. So it's not both is opposite direction. Based on Newton's third law, FC is equal but opposite. So FCE is equal to FEC, pulling and also pull in the chord in tension. So for equilibrium, meaning that the FCE is equal to FEC. So the force EC, the force of chord, is actually same equal to the force of the weight of the mass. Okay, sphere. So finally the free body diagram at knot C. So three forces acting. This one, the cable force on cable CB acting on knot. So because this one we neglect the weightless of the pulley, and that's on the some cable. So this tension is equal to this tension. So tension AB and also tension BC is actually one cable, the same tension. So we analyze with as a one tension FCBA, and then this one FCD is a spring on the knot C. So force of C acting on the knot. FC is the force of chord CE acting on the knot. So FCE is actually equal to the weight of the sphere. Okay, so this one free body diagram. So now we move to coplanar system. The coplanar system by the x and y. So a particle is subject to coplanar forces in xy plane. So we can resolve it into the unit vector I and unit vector j for equilibrium. So total force in x direction equal to 0, total force in y direction equal to 0. So all the forces here okay, we have the several forces on the coplanar forces in the x and y plane. For example, here we have F1, F2, F3, F4. So F1 here is the component F1 here, component the Fy for here. Then F2 the component of x here, component of y here. So F3 is the component of y here, component of x here. Component additional force 4, so the component of y here, component of x here. So the scalar equation of equilibrium requires the algebraic sum of the x and y component to equal to 0. So because this one is an equilibrium, so total force in x direction equal to 0, the total y in the y direction is equal to 0. So the procedure for analysis in the coplanar system, we have the free body diagram, establish the xy axis, label and all the unknown and known forces. We need to label all unknown and known forces. So the equation of equilibrium is basically they have two equation of equilibrium of particle is a total force in x direction is component equal to 0, total force in y direction equal to 0. So if let's say we have the spring force, we apply the equation of the linear elastic spring F equal to Ks. So when the negative result force is the reserve, so we can see the example here what we have here. So determine the required length of the cord AC so that the 8 kg length is suspended. The undeformed length or unstretched of the spring AB is 0.4 and the spring has stiffness of KAB 300 Newton per meter. So this one or this stretch, because this from this point to this point is actually is a 0.4, but we don't have, we need to calculate based on the linear elastic spring to determine this additional length here, and also we can minus up with 2 meters, so then we can get the length of the AC by using the theorem Pythagoras. Okay, so now we need to draw the free body diagram. Okay, so free body diagram at A. So because we have learned, so to eliminate the length, so chord A here is equal to the weight of length here. So this one is equal to the weight. Weight is 8 kg multiplied by constant G. So we have the 78.5 here. So the tension TAB is a spring force. So this one the tension AC is by the cable. So we have the TAC, TAB, and also the weight. So the three forces are acting on the knot A, so by the cable AC, force is spring AB, and the weight of the lamp. So if the force on cable AB is known, be due to the force equal to Ks. So total force in x direction equal to 0 by the TAB here, so minus the TAC, the component of x. So this one is the component of x. TAC resolved to the TAC resolved to x component. So we have the TAC multiplied by cos theta, cos 30. So because this one is a negative direction, so this one positive, this one is positive, this one negative. So whereby the total force in y, this one the TAB only the x, no component of y. So I think this one and there mistake here. It's not TAB, sorry. This one TAC. This one the TAC here. So this one is a TAC, is not the TAB. This one TAC, sorry. TAC, sorry, you need to take down here. Notice that this one TAC, not TAB. TAB all in x direction, no y direction. So TAC multiplied by sine 30. So sine 30 here, TAC. So you need to resolve to bring into the y component. So this one is the y direction is a positive for TAC in y component. The weight is the negative direction. That's why is the TAC sine 30 is positive. The weight is negative. Okay, so we are resolving these two equations. We have the two equations, two unknown. So we can solve here the first one. We can solve it for TAC. because it's only one known TAC, so we get a TAC 157.0 kilonewton. So we are substituting TAC into this first equation, so we get a TAB. Okay, because of this TAB is a free spring force, so TAB equal to KAB as AB, F is equal to KS, so equal to the TAB is 136. 3AB is equal to 136 equal to KS 300 multiplied by S. So we have here S 0.453. So the for stretch length, the total length is actually equal to the unstretched plus dengan additional length. So the unstretched is 0.4, the unstretched is 0.4. After pull the tension, we have the 0.5453. So the total length is 0.853. So from here to here, 0.853. 0.853 for the from A to B. So A to here, not C. So here, so you divide 2 meter minus the AB. So the 2 meter minus 0.853. Okay. So we either then we can get this length. So we have the theta. So we can solve by the cos theta. Okay, so another way we have the we need to have the this one 2 meter in x direction. So this one x direction, you resolve the length of AC to in x component. This one cos theta. That's why for horizontal distance BC, 2 meter is equal to LAC. LAC component of x multiplied by cos theta, cos 30 plus 0.853. From A to B is 0.853. So we have the LAC 1.32 meter. So we are solving this equation. So the length of the cable AC is 1.32 meter in order to the lamp is suspended. So I think that's all for this chapter. We are done for this chapter. Basically, you must understand how to draw the free body diagram. You must understand to extract all the known force and unknown forces. If the forces apply and on spring, so you need to using this equation. F is equal to F into KS. Okay, see you in next chapter, chapter number 4. I hope you can do all the problem. See you again. Thank you. Bye bye.